Dear students, now we are going to see the subject linear integrated circuit. Under that, the topic is BJT differential amplifier acts as active load. On completion of this BJT differential amplifier acts as active load, students can explain the working of differential amplifier with active load. Differential amplifier is mainly designed with active load to increase the differential mode voltage gain. The open loop voltage gain of an operational amplifier is needed to be as large as possible. This is got by cascading the gain stages, which increases the phase shift of and the amplifier also becomes vulnerable to oscillations. The gain can be increased by using large values of collector resistance, and for such circuit the voltage gain is given by a differential gain ADM is equal to GM into RC. GM represents the transconductance of the transistor. To increase the gain, the collector current and the RC product must be made very large. However, these are the limitations in IC fabrications, such as a large value of resistance needs a large chip area. For a large RC, the quotient drop across the resistor increase and a large power supply will be required to maintain a given operating current. A large monolithic resistor introduces a large parasitic capacitance which limit the frequency response of the amplifier. For a linear operation of differential pair, the device should not be allowed to enter into the saturation. So this limit the maximum input voltage and can be applied to the base of transistor Q1 and Q2. The base collector junction must be allowed to become forward biased by more than 0.5 volt. A large value of load resistance produces a large DC voltage drop, which is equal to emitter current by 2 into RC, so that the collector voltage will be VC equal to VCC minus IE by 2 into RC, and it will be substantially less than the supply voltage VCC. This will reduce the input voltage range of the differential amplifier. Due to the reasons cited above, the active load is preferred in the differential amplifier configurations. A simple active load is constructed by using a current mirror circuit. This active load consists of transistor Q3 and Q4. Here the Q3 is connected as a diode with its base and collector are short circuited, and the circuit is shown to drive the load current RL. When an AC input voltage is applied to the differential amplifier, the various current of the circuit are given by IC4, IC3, which is equal to the collector current of Q1, that is equal to GM into differential input voltage by 2. So the IC4 is equal to IC3 due to the current mirror action. That is, the input current is equal to output current. Then IC2 is equal to minus GM into VID by 2. The load current IL entering into the next stage is given by IL is the difference between IC2 and IC4, which is equal to minus GM VID by 2 minus GM VID by 2, which is equal to minus GM VID. Then the output voltage from the differential amplifier is given by V0 is equal to minus IL into RL, which is equal to GM RL VID. The AC voltage gain of the circuit is given by AV is equal to output voltage by input voltage, that is equal to GM into RL. So the amplifier can amplify the differential input signal, and it provides a single-ended output with a grounded reference. Since the load RL is connected to only one output terminal, this is made possible by the use of current mirror active load. The output resistance R0 of the circuit is that offered by the parallel combination of transistor Q2 and Q4. Q2 is an NPN transistor, Q4 is an PNP transistor, and RR is equal to R02 and R04 parallel connector. So BJT amplifier with active load, current mirror as active load is shown in this figure. So Q1 and Q2 form the differential amplifier stage. Q3 and Q4 that forms the current mirror circuit. This current mirror is connected as the load for the differential amplifier. Analysis: the collector current of all the transistors are equal. So IC1 equal to IC2 equal to IC3 equal to IC4, which is equal to emitter current by 2. The collector emitter voltage of Q1 and Q2 are given by VCE1 minus VCE2 equal to VC minus VE equal to VCC minus VEB minus VEB, that is equal to VCC. So the equation shows that the offset is higher than that of a resistive loaded differential amplifier A. This can be reduced by use of emitter resistor for Q3 and Q4 and a transistor Q5 in the current mirror load. CMRR, the differential amplifier using active load that provide a high voltage gain to the differential input signal and a single-ended output, that is reference to the ground, is obtained. The differential amplifier which provide a conversion for a differential signal to single-ended signal is necessary in differential input signal entered output amplifier. The op-amp is one such circuit. The changes in the common mode signal of the bias current source. This introduces a change in the collector current and identical change in collector current of Q1. The change in Q1 collector current produces a change in PNP load device, thereby a change in collector current of transistor 4, which is the collector current of Q4. The current IC4 is in such a direction as to cancel the change in the collector current of transistor Q2. As a result, any common mode input does not cause a change in output. The voltage gain of the differential amplifier is independent of the quiescent current IE. This makes it possible to use very small value of emitter current as low as 20 microamps while still maintaining a large voltage gain. A small value of emitter current is preferred since it results in a small value of bias current and a large value of input resistance. A limitation in choosing a small value of emitter current is it will result a pure frequency response of the amplifier. So the improved differential amplifier circuit with active load is shown in figure. So one input of the differential amplifier is grounded. Only one input V1 is alone active. So differential to single-ended conversion and output stage is given. Here the gain is improved by introducing an additional transistor in the output of the differential amplifier. The AC signal analysis of differential amplifier that can be made using the circuit model as shown above. The differential input transistor pair produces equal and opposite current whose amplitudes are given by GM2 VID by 2 at the collector of Q1 and Q2. The collector current IC1 is fed by the transistor Q3 and it is mirrored at the output of Q4. Therefore, the total current I0 flowing through the resistor RL is given by I0 is equal to 2 GM2 VID by 2. That is equal to GM2 into differential input VID. Then the output voltage V0 is equal to I0 into RL minus GM2 RL VID. The differential mode gain AD of the differential amplifier is AD is equal to output voltage by input voltage, that is equal to GM2 into RL. This current mirror provides a single-ended output which has a voltage gain equal to maximum gain of the common emitter amplifier. The power of current mirror can be increased by including additional common collector stages at the output of differential input stage. The equivalent resistance is a parallel combination of R02, R04 and RI5. Which is approximately equal to RI5. The gain of the differential amplifier stage is ADM is equal to GM2 into R requirement, that is GM2 into RI5 equal to beta IC2 by IC5. So some of the possible question is for the given circuit, the output current I0 is equal to 5 microamps, reference current is 2 milliamps, VB is equal to 0.7 for both Q1 and Q2, VT is equal to 25 millivolts. What's the value of R2? So solution is VB1 minus VB2 is equal to VT ln of I reference by I0. So substitute these values and we are getting 0.015 volt. So from this you have to find the R2 value in terms of I0 into R2 is equal to 0.15. So R2 is equal to 0.15 divided by I0. The I0 value is given in the problem. So substitute that and you get the R2 is equal to 30 kilo ohm. Thank you for watching.